Okay, sorry for the delay. Hopefully this is in presentation mode right now. It is on my screen on my end. I'm hoping it's showing full screen. So the purpose of Chapter 102 is requiring people conducting earth disturbance to develop, implement, and maintain BMPs to minimize the potential for accelerated erosion and sedimentation and to manage post-construction stormwater. Why do we do this? To protect, maintain, reclaim, and restore water quality. It's a very water-focused program. Any permitting and inspections under the chapter are performed to protect water quality during earth disturbance. So why is that regulated? Erosion is a natural process, of course. Wind and water gradually wear away and transport soil and rock. However, during earth disturbance activities, the likelihood of accelerated erosion is increased, and this causes pollution to waterways. The EPA lists sediment as the most pervasive water pollutant. This may be a fact you didn't know or consider. When excessively high in water, sediment causes a myriad of problems, including degrading natural habitats, lost recreation, decreased drinking water quality, and higher treatment costs. Deposition downstream leads to increased maintenance costs for flood control schemes, culverts, bridges, and ports. It's not only sediment that's leaving. Sediment carries a variety of other pollutants that further degrade water quality. There are many studies that seek to put a cost on accelerated erosion, and cost estimates vary widely. An off-cited study from 1995 lists the economic impacts in the United States as high as over $44 billion per year. This includes loss of productivity of agricultural land, increased cost for infrastructure maintenance, loss of recreational opportunity, and other factors. So earth disturbance is regulated. Let's get into some of the specific requirements. No matter the size of earth disturbance, best management practices are required and should be used. This can be as simple as seeding and mulching right after a small home project, or putting up silt fence downslope of small driveway grading project. But no matter the size of the earth disturbance, efforts should be taken to limit accelerated erosion. Generally, once earth disturbance is 5,000 square feet or greater, a written plan is required under the regulations. This is just under 1/8 of an acre, approximately the size of a football end zone. The overall goal of a written plan is to minimize accelerated erosion and sedimentation to surface waters. A written plan is designed to minimize the extent and duration of earth disturbance, protect existing drainage features and vegetation, and minimize soil compaction. The written E&S plan contains a narrative and plan drawings with 15 distinct items that need to be included and are outlined in the regulations. For example, site topography, soil types, the construction sequence, and the sequence of BMPs to be used are included. The review of plans is standardized and technical, done through the lens of the Chapter 102 regulations and the DEP Erosion and Sediment Control Manual. The 563-page Erosion and Sediment Control Manual is organized by chapter for different BMPs and construction activity, such as site access, channels, outlet protection, sediment traps and basins, and stabilization. This manual provides guidance and procedures on BMPs used to minimize accelerated erosion during earth disturbance. Our staff uses the manual when evaluating a plan's adequacy. If a plan is inadequate, ACCD would provide deficiency comments and work with applicants and their consultants to make adjustments to get to an approved plan. For a few general examples, perimeter control, such as silt fence that filter sediment-laden water coming off the site and sheet flow, are sized by slope length and slope percent. Silt fence comes in a variety of sizes and strengths. The longer the slope length or the steeper the slope percentage, a larger fence is needed. Our staff would check this during a plan review. Sediment basins, which collect and detain sediment-laden runoff from a larger area so that soil particles can drop out before water is being discharged, they have requirements in part that they cannot be on a live stream channel. They have to be sized to hold at least 1,000 cubic feet of sediment per disturbed acre draining to the basin, and they have required discharge capacity of 2 cubic feet per second per acre. These are a few examples of BMPs and considerations ACCD staff make when they're looking at a written plan. It's appropriate to slow down here and acknowledge how broad earth disturbance activities are. The regulations cover construction and development, but it also applies to timber harvests, agriculture activities, and any other activities that involve earth disturbance. Silviculture and agriculture have different BMPs and different plan requirements. They're evaluated differently than commercial or residential construction. These activities largely use non-structural best management practices, such as vegetated filter strips, fencing, exclusion areas, and critical area stabilization and planting to minimize accelerated erosion. For example, a farmer is not required to put silt fence or sediment basins and traps downslope of a recently tilled field. The regulations set permit requirements for various activities by acreage threshold. Most development and construction activities, and what I'll focus on from here on out, require a permit at 1 acre of disturbance. This is for housing, commercial, etc. development activities. Once a permit is needed under Chapter 102 for over 1 acre of disturbance, a post-construction stormwater management plan, along with the written E&S plan, is required. So why are there stormwater management requirements for new developments? Developed impervious surfaces substantially change hydrology on a given site. Consider the graph showing a hypothetical stream discharge in a more post-development impervious watershed, the solid line, and a more pre-development pervious watershed, the dotted line. In the pre-development watershed, the dotted line, during a storm, water is hitting fields and forests, is absorbed by vegetation and soils. Eventually, during a rain, there'll be runoff that gently flows towards the stream. The stream gently rises and falls after the storm is ended. In the post-development watershed, runoff quickly occurs from roofs, streets, and parking lots. This causes the stream to discharge and rise very quickly. Think flash flood, think increased peak rate situations. The runoff is also carrying other pollutants from the land that degrade water quality, such as hydrocarbons, nutrients, and litter. Soon after the storm ends, stream discharge rapidly decreases. Stormwater management under the Chapter 102 regulations accounts for rate, volume, and water quality for newly developed areas. Similar to an E&S plan, the PCSM plan contains 15 distinct items. An important difference is the inclusion of a characterization of pre- and post-developed hydrology conditions to quantify the changes in rate, volume, and water after development. Similar to the E&S plan, construction sequencing and the proposed stormwater best management practices that are to be used are included here. PCSM plans under Chapter 102 control for changes in rate up to the 100-year storm, volume and water quality for the 2-year 24-hour storm, comparing pre and post development. They have to manage the change pre to post development. There cannot be an increase in rate or volume under these parameters. The regulations require that 20% of any impervious areas to be disturbed are considered meadow in good condition for the pre-development analysis. This conservative modifier results in more strict controls for stormwater, including volume and water quality. A 2-year or 10-year or 50 or 100-year 24-hour storm is the maximum 24-hour precipitation for a storm that would occur on average every 2 years, 10 years, 50 years, etc. These values can be looked up at the National Oceanic and Atmospheric Administration's Atlas 14. NOAA for short is the agency, and they tabulate precipitation frequency. For Allegheny County, the 2-year 24-hour storm is roughly 2.5 inches, depending on where you are, and the 100-year 24-hour storm is roughly 5.25 inches. NOAA's Atlas 14 is frequently updated with new data across the United States. It's important to note that ACCD does not perform technical review of post-construction stormwater management plans. That is done by the local municipality, or for some individual permits, by the PADEP. Volume control can be thought of the removal of the pre to post change of the 2-year volume. This is primarily done through infiltration and evapotranspiration, which includes both evaporation from the land and soil and transfer of water vapor to the atmosphere by plant transpiration. Infiltration basins and rain gardens are common volume control BMPs. Rate control is primarily done by outlet structures and structural BMPs. The 2 through 100-year storms are routed through the developed site, and the discharge rate leaving the site in cubic feet per second is controlled by orifices or weirs. In the attached example, as this pond fills, the discharge rate leaving the site for progressively larger storms is controlled first by a 4-inch circular orifice, then an 8-inch circular orifice at a higher elevation, up top at an even higher elevation, a 36-inch by 13-inch orifice, and finally the top of the grate overflow. Developed surfaces contribute pollutants during runoff and stormwater. For water quality, the regulations compare pollutant loads for different cover types pre to post development for total suspended solids, total phosphorus, and total nitrogen. BMPs need to be designed to manage the change and increased pollutant load for these 3 measurements after construction for the 2-year storm volume. Just a few examples of common stormwater controls you may have seen around your community. Rain gardens on the left are excellent controls for volume and water quality control. By comparison, dry detention basins are primarily used for short-term detention and outlet control rate. They're rate controls. There's not as much water quality benefit. There's no infiltration. They're supposed to be dry. For larger sites, typically several controls are used after development to manage for these 3 different variables: rate, volume, and water quality. So we know over an acre a permit's required. What is that actual permit? Nationally, the NPDES, or National Pollutant Discharge Elimination System, permitting system controls water pollution by regulating point source discharges. There are many NPDES permits and programs. They cover anything that would authorize the discharge of water. They include activities from sewer treatment plants to industrial wastewater discharge. For disturbances over an acre, the permit required is the general or individual NPDES permit for stormwater discharges associated with construction. These permits authorize stormwater discharges from construction sites pursuant to the terms and conditions of the permit. Once construction activities are completed, the applicant must formally terminate the permit through the notice of termination process. This process includes a final inspection of site stabilization and a final inspection of stormwater facilities before a permit is closed out. The basic parts of the NPDES permit are a notice of intent, which is the application That includes the consultant's name, the applicant's name, basic stormwater tabulations, location, addresses, contact information, and the associated ENS and PCSM plans. Please note there are other considerations before a permit is issued. That would include whether or not there are impacts to threatened or endangered species, and whether or not there are impacts to historical sites. Okay, we've covered basically what Chapter 102 regulates, and we've gone through the general requirements for erosion control and stormwater plans, and when an NPDES permit is needed. Just want to talk a little bit specifically about Allegheny County Conservation District's delegation agreement. Our formal delegation from DEP is a 27-page signed document that covers both the conservation districts and DEP's responsibilities under the agreement. Our Chapter 102 delegation with DEP was last formally updated in December of 2016, and this agreement is updated periodically. Allegheny County Conservation District's responsibilities under the delegation fall into three general areas. These are plan and permit reviews, inspections, and outreach. In 2019, ACCD completed over 550 ENS plan reviews. These include sites that are under an acre, timber harvests, and also NPDES permitted sites. There are initial reviews and also the follow-up reviews, and we have deficiency comments and requests that developers and their consultants make changes. We inspected complaints and permitted sites under this delegation. For sites that are permitted under Chapter 102, ACCD staff performed over 900 inspections last year in 2019. During inspections, when sites have compliance issues, ACCD sends a formal written inspection report to the contractor and developer. A follow-up inspection is then scheduled to ensure all non-compliance items are taken care of. ACCD strives for voluntary compliance. In instances where voluntary compliance cannot be achieved, ACCD does have an enforcement delegation and follows DEP's compliance and enforcement manual. We have several different routes to achieve compliance. Finally, under the delegation, we have outreach obligations. We have educational materials at our physical office and online at our website for the general public. Last year, our regulatory staff spoke at 13 different events in 2019. Our biggest outreach event, we hold an annual workshop for contractors, developers, and consultants. We discuss best practices, invite outside speakers, have regulatory updates, and exchange information with these stakeholder groups. In 2020, we had over 175 attendees over 2 days, and we had about 90 people on the waiting list. So our workshop continues to grow year to year. I think finally we'll take a higher level overlook at a site that was developed under the NPDES permit and Chapter 102 regulations. We'll discuss some of the erosion controls that were used, the stormwater management BMPs used, and compare the site pre and post development. So this is obviously an all impervious site. This is a 25-acre site in the east central portion of the county and entirely impervious before development. When it was redeveloped, because over 1 acre of earth disturbance was proposed, a NPDES permit for stormwater discharges was required. The permit was submitted and reviewed to our office by Allegheny County Conservation District, and during construction, ACCD performed 6 inspections at the site. This is a picture pre-development. As you can see, when it was originally developed, it's 100% impervious. There were no stormwater controls for volume, rate, or water quality. There was storm sewer on the lower end of the site. It was collected and discharged, put into pipes and as quickly as possible, gotten off the development pad. It went towards a small unnamed tributary that went to the towards the Monongahela River, and that tributary was heavily incised and damaged from peak flows from the impervious area. Now, when they came in for redevelopment and got an approved plan, first during construction, several different erosion controls were used that you've probably seen at other developments. A rock construction entrance used for all construction vehicles leaving and entering the site. The BMP limits sediment track out from construction vehicles and restricts movement to one or a few defined points. It's a site access best management practice. Must be at least 50 feet long, so tires, even larger construction vehicle tires, have several rotations. Uses larger AASHTO #1 rock. Think about fist size or railroad ballast size rock, and have a geotextile underlayment. The geo underlayment helps prevent underlying soil from pumping and clogging the BMP. Like anything, it requires regular maintenance, including placing more rock as appropriate. For larger active sites, typically a broom and sweeper attachment are also on site to clean track out from public roads. It can also be upgraded for special protection watersheds. You can put a wash rack and sprayer to spray tires off before leaving the site. Compost filter sock was used here. It's like silt fence. It's a perimeter control that filters sediment-laden sheet flow from disturbed areas. It has a better efficiency at filtering sediment out than silt fence does. It's sized by slope percent and length. If there's a larger slope length or steeper slope percentage, a larger compost filter sock is required. It gets up to 32-inch diameter. It's placed on the contour and staked every 10 feet. It's not really for concentrated flows. This can be installed in the field. They can actually bring a truck out and blow the material into the sock in place. Some of the smaller diameters come pre-made on pallets. When the BMP is half full of sediment, half the height of the stock, it's time to maintain it. If it gets ripped or otherwise damaged during construction, it would need replaced. Finally, the most important long-term erosion control, seeding and mulching that leads to permanent vegetation. Once disturbed areas are at final grade, they're seeded, mulched. Other controls, such as compost filter sock and perimeter controls, that can only be removed once the site is stabilized. With vegetation, the standard is 70% uniform stabilization. Seed mixes vary depending on soils and activity. Native mixes and perennial species are best. For straw mulching, at least 3 tons per acre is the application rate. At this rate, bare ground is just invisible. The straw isn't matted or clumped, but provides a thin, uniform covering. So this was farther into construction and completion of the site. You'll note originally the entire 25 plus acres was completely impervious. There's a substantial difference, obviously, looking at this Google Earth image when it was almost completed. The redevelopment resulted in substantially more green space on the property, including a nearly 2-acre infiltration basin and just over 3.5 acres of a restored meadow where all of the pavement was torn out, the subground was scarified, topsoil was brought in, and it's a 3.5 acre meadow and grass, up to your waist type of restoration. So I'll talk really briefly about some of the controls afterwards. The infiltration basin. This provided volume, water quality, and rate control. You can see the outlet structure in the upper left corner of the image to control rate discharge from the site. Remember previously, all that stormwater collected and went directly into a heavily damaged small unnamed tributary. Now there's a 2+ acre heavily vegetated infiltration basin that collects it, settles out pollutants, and discharges at a controlled rate. The site also, as you remember from the overhead view there from Google Earth, included a large 3.5 acre landscape restoration best management practice for water quality and volume credits. Native deep-rooted species were used to be habitat friendly and also promote the infiltration of stormwater. Look at the large difference in root penetration for Kentucky bluegrass, common lawn cover, and the other native grasses and plants that can be used. Using this BMP involves some serious site preparation. The pavement had to be removed from that 3.5 acres. The subsurface was scarified and decompacted, and topsoil was brought in to prep the area for planting. These are the actual volume credits for the 2-year storm on this site. The infiltration and landscape restoration provided over 100,000 cubic feet of volume reduction for the 2-year storm. Pre to post development, 115,000, so pretty substantially over 100,000. Remember, there was no stormwater control at all before. It was just an entirely impervious site. So redevelopment under these regulations really has an improvement in sincere stormwater impact. For comparison's sake, if you just compare that to how many rain barrels that type of volume would fill, and rain barrels are just that. They're barrels that attach to roof leaders, capture rain runoff during a storm. They're great stormwater controls most homeowners can reasonably install to provide some DIY stormwater control. So each 55-gallon rain barrel is 7.35 cubic feet. So it would take over 15,000 rain barrels to meet the volume control provided by the infiltration basin and the landscape restoration. If you assume 2.5-inch rain and each one of those barrels was serving 36 square feet of roof surface. So a really substantial impact post-development. Some takeaways from today. Chapter 102 specifically regulates earth disturbance. The regulations require erosion control and stormwater best management practices be used during earth disturbance and after development because both have detriments to water quality. This is an extremely broad category, earth disturbance, and the regulations are written to set different requirements for different activities and types of development. Finally, Allegheny County Conservation District has an active and robust program. By several metrics, including the number of plans and permits reviewed, number of sites inspected, ACCD does have the largest Chapter 102 program out of the 64 delegated conservation districts across Pennsylvania. In the last year alone, we added 2 more full-time staff, specifically for inspections and plan reviews. The 102 program is going to remain a cornerstone of our district in the future. At this time, we'll take some questions from the chat box. I'd also mention we have several other webinars up on our website right now. We have one for soils, tree planting, introduction to streams and flooding, and our nutrient management program. So do check out our website, our Facebook, and other social media pages. It's also Conservation District Week, so statewide, a lot of conservation districts will be putting out some detail and different media. So do check those out, and you know, hopefully they have something valuable you'd like to watch.
Thanks, Matt. That was a great presentation. We don't have any questions in the chat box right now. Give people a couple of minutes if they have any last minute questions they want to ask. If not, Matt's contact information is on the slide, so you can feel free to email him directly. Okay, here's a question for you, Matt. If you meet the volume requirements, does that automatically mean that you meet the water quality requirements?
That's a good question. I don't have a specific answer for you with that. I've looked at the new BMP spreadsheets, and essentially they assign a concentration for different cover types. But if it's not all routed through a volume BMP, because you're looking at the effluent loading too, I do not think you would automatically meet water quality just because you met volume.
Okay. Next question, does the Conservation District review water quality? And if so, do you have experience with the new spreadsheets put out by DEP?
Sure. Our reviewers have looked at the new spreadsheets. We do not do a technical review of the stormwater plan. So we do perform a completeness review, for example, making sure infiltration testing, construction details for outlet structures, and soil amendments for rain gardens, et cetera, is completed. But we do not perform a technical review at the calculations for water quality.
Okay. For the site example you mentioned, since it was already 100% impervious pre-construction, why did the developer need to put in any stormwater practices? I.e., they weren't increasing impervious area, so the stormwater situation wasn't worsened by construction per se.
Yeah, that's a great question. So the requirements for stormwater, as I mentioned under the regulations, they have this conservative modifier where when you're characterizing the site for your pre-development analysis, the consultant has to consider 20% of any impervious area that's going to be disturbed as meadow in good condition. So looking pre to post, it just artificially sets the stormwater reality as being better than it is. So that's a way these regulations kind of reclaim stormwater problems of the past, is that modifier considering 20% of impervious to actually be meadow in good condition.
Great. Anybody else have any last questions? I'm not seeing anything else pop up, Matt. So, oh wait, hold on. Have you seen compost filter socks used for check dams?
I've seen it out in the field as, you know, a quick way to slow erosion in channels. It's not really an appropriate use per the manual. They really shouldn't be used in any areas of concentrated flow. It's a sheet flow BMP. It'd be better to use an actual rock check dam that was sized appropriately for the channel it was in than a perimeter control, either silt fence or a compost sock.
That's going to be our last question. Like I said, if you think of anything else, feel free to email Matt directly. And thanks for a great presentation, Matt.
Yeah, thank you. And do check out our website and other social media for other webinars we have available.